So the thing that I went and did over the weekend to kind of help me break down quadratic functions a little bit better is I just started kind of from scratch again. So what we need to know about quadratic functions, the first thing is the parent function. What gives a function away or an equation away that it's quadratic? So if I give you guys an equation or a function, what gives it away that it's quadratic?
X and the y?
No, not x and the y, because that's just an ordered pair. What about the x value? So if I give you a quadratic function, this just means function, which basically means it's your output, which is your y value, okay? What's that x going to have to it? What power? What degree? For it to be quadratic, what degree? 2 to the second power, okay? So that's your parent function. Anytime you see it to the power of 2 or the highest degree is second, you know that it's going to be a quadratic. Now, quadratic functions have a standard form. They have a specific form that we want them to be written in. So it's going to be the function, which basically, you guys remember, it's just like your y, okay? So the function of, and then our standard form is going to be ax squared plus bx plus c. Now, the ABC is a variable that's going to represent a number. So when we see a function, a quadratic function, instead of having ABC, we're going to have a number in place of those, okay? But the x squared and the x will remain the same. So that's going to be our quadratic function in standard form. Now, when we go to graph quadratics, what kind of graph are we going to end up with? So when we go to graph a quadratic, what kind of graph is that?
U.
Which is called what? Yeah, parabola. That weird word, right? So it's going to be a parabola. When I have a graph, it's real easy to determine what my axis of symmetry is. But if I just give you a quadratic function and it's not graphed, it's hard to determine what that axis of symmetry is. So I'm going to give you a formula that's going to help you find it. So the axis of symmetry is going to be your x value. So it's going to be x equals negative b divided by 2 times a. Okay? So axis of symmetry, it's real easy to get when we have that graph right there in front of our face because it's just the x value where that parabola, where that symmetry, right in the middle of that graph where it is located. But if I just give you a quadratic function like the equation or the expression, it's real hard to find what the axis of symmetry is. Then the y-intercept. The y-intercept, there's 2 ways that you can really find it, but the easiest way is just to refer to your c. So the c in your standard form right here, that's going to be your y-intercept. Or where the graph crosses through your y-axis. Okay? So those are going to be the terms that we're really going to focus on today. Finding the axis of symmetry, finding our y-intercept. Now, what I put on the top of your notes that you guys have are the goals. So hopefully by the end of today's lesson that we'll be able to identify and define characteristics of a quadratic, which are these terms right here that I'm looking for, among a couple other that we're going to see. Determine if the parabola will open upward or downward, minimum or maximum, based on the function. And then we're going to be able to find the vertex equation of the axis of symmetry and the y-intercept. Also the domain and range, okay? So these are all things that we should be able to do when we get through today's lesson. Okay, so when I'm looking at this graph, I want you guys to be able to help me find the vertex. So we talked about the vertex in 9.1. Where is the vertex located? The very bottom, or it could be the very top. It just depends on where my bottom of my grid is going to be. So this right here is going to be my vertex. Okay, so if you guys would label that, ooh, that's way too big. If you would label your vertex just so you remember, that would be great. Now remember, your vertex is also an ordered pair. So your vertex is written as an ordered pair. What would be the ordered pair of this vertex? And remember, when you do ordered pairs, you always find your x, then your y. So we started our origin, which is where the x and the y axis intersect, and then we find our x value. So how many over do I go? 1, 2, and then what about for my y? So my vertex would be -2, -8. Now, my axis of symmetry runs where? Right through the vertex. It's going to separate that parabola so that if we fold it over, it would have the same exact ordered pairs on the opposite side. Okay? Oops. So this right here is my parabola. That didn't turn out. Yeah, I'm going to make my eraser a little bit smaller here. So I'm going to label my axis of symmetry.
How do you get -2, -8? Oh, yeah, wait, no, it's okay.
It's the ordered pair of the vertex. Are you sure you get to see it?
I just saw it.
Okay. So that line that separates our parabola, or what divides it exactly in half, is going to be our axis of symmetry. Now again, when I give you a graph, it's really easy to identify our axis of symmetry. But if I just give you the quadratic function written in standard form, you're going to have to use the axis of symmetry formula. Okay? I know, cross your fingers. It's like this all day, so I don't have to take Braden to soccer. Sorry. Okay. So let's put this to use now. So when we're identifying the characteristics from a graph, we have 3 things that we're going to do. We're going to find the vertex, we're going to find the axis of symmetry, and then we're going to find the y-intercept. Okay? So if I give you a graph, the first thing I want you guys to be able to identify is the vertex. Okay? So what's the vertex of this specific graph? -2. Okay, but we write our vertex as an ordered pair. So my x value is -2. What about my y value? Oh, look like here. Where's my y value?
0.
0, yeah. Okay. Now, the axis of symmetry. The axis of symmetry represents my x value. Where does that axis of symmetry run through? So if my axis of symmetry is right here, it goes through x equals -2. Okay. So axis of symmetry would be -2. Now the y-intercept. Where does my parabola cross my y-axis? What was it?
I thought it was 4.
You're right, it is 4. Now, my y-intercept is 4, so how would I show that as an ordered pair? 0, 4, because my x value would be 0, my y value would be 4. I would like to see it written as an ordered pair. Okay? So that's identifying characteristics from a graph broken down a little bit differently, okay? Any questions on how I got any of these numbers? So we know that the vertex is either going to be the minimum or the maximum. It's basically the top, the highest point, or the lowest point of the parabola, and it's written as an ordered pair. My axis of symmetry is right where I could, right in the middle of that graph. Right, it goes right through my vertex. And then my y-intercept is where that crosses through the y-axis. Now, giving you a graph like this, it's pretty easy to see. So let's look at one more. Let's look at the second example, okay? So let's look at this second example here. What is my vertex going to be? Is it going to be at the highest point or the lowest point, Maddie? Okay, and what's that going to be then?
Is it 2 and 8 versus switched?
No, you're perfect. You did. Your x value is 2. Your y value is 8. So the vertex of this parabola is 2, 8. That's your ordered pair. Okay, what's my axis of symmetry?
2, 0.
Oh, what's my axis of symmetry? Just x equals?
X equals 2.
Yep, x equals 2.
I don't know.
You got it. And then where does my parabola cross my y-axis for my y-intercept?
0, 4.
0, 4. Good. Okay. So this is the fairly easy part. You're going to pop that and it's going to go everywhere. So this is the fairly easy part. I'm just going to set it right here, okay?
I don't need it.
Okay. Now, let's make it a little more complicated. So now, we're going to look at identifying characteristics from functions. Okay? Now, what I want you guys to first do, step 4, put a line through your step 4. Do me a favor. Step 4, cross it out. And substitute. Look at me using math words. And go ahead and put in step 4, you're going to find the y-intercept, which is C in standard form. So you're going to basically cross out what I had on your note sheets and write that in. It's a much simpler way of doing it. Okay? Okay, so when I give you a quadratic function where it's not graphed out for you, I'm still going to want you to find the axis of symmetry. I'm still going to want you to be able to identify the vertex, and I'm still going to want you to be able to find the y-intercept. Okay? But it's going to be a little bit more in depth rather than just looking at the graph and be like, oh, here's the vertex, find my ordered pair. You're going to have to take these numbers and you're going to have to first find the axis of symmetry, then you're going to have to use that number and substitute into the formula to find your y value. So basically these steps are going to help you. Okay, so step 1, the first thing that we're going to do is find the axis of symmetry of the quadratic function. Step 2, find the vertex using the value found for the axis of symmetry as the x-coordinate of the vertex. And I'll show you, I know that's just a lot of word usage right now, but once I show you, I think you guys will get it. To find the y-coordinate, you substitute that x value in there, and that will give you the original equation. That will give you the vertex. And then for the y-intercept, you guys remember, is just that c value when it's written in standard form. So what does this all mean? Right now, it doesn't mean a whole lot to you. So let's look at a quadratic function. So we have y equals 2x squared, y equals 2x squared plus 6x, y equals 2x squared plus 4x minus 3. So that should be plus 4x on you guys, right? Okay, so we have y equals 2x squared plus 4x minus 3. Okay, the first thing that I want us to find is the axis of symmetry. But you're like, well, Ms. Lydia, can we have the vertex first, though? That's the first thing that's on our paper. We can't find the vertex until we find the axis of symmetry. So step 1 in our notes say to find the axis of symmetry. It's not as easy this time just to look at a graph and be like, oh, it's right there, because we don't have a graph. And we don't know how to graph these yet. So what we're going to do is look at step 1 where it says find the axis of symmetry. What's the formula it says to use? To find the axis of symmetry, what formula am I using? So step 1, x equals
b negative b over 2a.
Okay, now remember, my standard form is written as y, or the function of x, equals ax squared plus bx plus c. Okay, so we're going to substitute these numbers in where they go according to our formula. So what I'm going to do, what do I substitute in for b? So what number represents b?
Negative 4, or sorry, positive 4.
Okay, so I'm going to put, remember when I substitute, I put a parenthesis around it. So I have negative, parentheses, 4, in parentheses, divided by 2, and what do I substitute for a?
2.
2. Any questions where I got these numbers?
No, wait.
Okay.
I do it.
So I'm using this formula for my step 1. Remember my standard form? ax squared plus bx plus c. And I said these numbers are going to represent the variables when we get into quadratic functions. So here's my formula, right? What do I need to substitute for b? Well, which number is in my b spot?
Oh,
4. Okay, then I come down 2, and what do I substitute A? Which number's in my A spot? Okay, so that's where I got him. No, that's okay. So what's negative times 4? What's negative times 4?
Negative 4.
Okay, and what's 2 times 2?
4.
And then divide it out, which equals?
Negative 1.
Okay, so right there we just found our axis of symmetry. So what does my axis of symmetry equals?
Negative 1.
How do I write it?
X equals negative 1.
Okay, you're going to need to remember that the axis of symmetry is x equals negative
How
1.
did you get the negative 1 out of 4? Did you,
Negative times 4 is negative 4. 2 times 2 is 4. So negative 4 divided by 4 is negative 1.
Oh, you divide.
Okay?
So the axis of symmetry is negative 1?
X equals negative 1. Yes, ma'am.
Is it on the top of it? Like on like the further. Is it the.
Yep. Okay, so now we're able to find the vertex. Now, according to our notes, step 2 says, find the vertex using the value found for the axis of symmetry as the x coordinate of the vertex. Okay, so what that basically means, we're going to come back, we're going to use this exact same quadratic equation, but this time for the value of x, what do I substitute for it? What do I substitute for the value of x? I use the value from our axis of symmetry. So what did we say x equals?
Negative 1.
So every time I see the x, what do I substitute for it?
Negative 1.
Okay, so right here, guys, I'm using the exact same quadratic function. This time when I see x, because we know that x equals negative 1, I'm going to substitute it in for negative 1. Now, once I substitute for x, what am I solving for? What will that solve for? If I substitute for x, what variable will I have? Y. So let's look. So I'm going to have 2. What do I substitute for x, Riley?
2.
What do I substitute for x? What does x equal?
1. Negative 1.
Negative 1. So plus 4. Oh, there's an x, so I'm going to substitute a negative 1 plus,
Minus 3.
yep. Okay, so here we go. This goes all the way back to our first unit together where we started order of operations. Looking at this, where do I start solving for order of operations, which is PEMDAS? Do I have a group of numbers within parentheses? No. So then after P is my E. Do I have an exponent? Yes. So I'm going to have to find negative 1 squared. So what's negative 1 times negative 1? Positive 1. So I rewrite my equation. So I have 2 times 1 plus 4 times negative 1 minus 3. Okay, after exponents, I then do multiplication and division, working from left to right. Where's my multiplication? Right here. So go ahead and simplify that for me, Maddie.
Oh, 2 plus negative 4 minus 3.
Okay. And then our last step, we're going to simplify left to right. We're going to add and subtract, which it's all subtraction. So what's 2 minus 4?
Negative 2.
And then I bring down that negative 3. So what's negative 2 minus 3?
Negative 5.
Negative 5. Okay. So what equals negative 5? What value in our ordered pair? Now what value is this? The y. So y equals negative 5. So the vertex is made up of an ordered pair. What's an ordered pair made up of, you guys? X and? What's my x value?
0.
What's my x value?
Negative 1.
What's my y value?
Negative 5.
There's your vertex. Okay? So to find your vertex, when we just have the quadratic function and not the graph, we first have to find our axis of symmetry. Then we have to find our y value, and then we get our ordered pair.
Your pen matches your shirt.
Oh no, I always color coordinate. Okay, y-intercept. How do I find my y-intercept? Well, that's going to be step 4 on your sheet. So what's step 4 say for your y-intercept? It's your what value? The what placeholder in our standard form quadratic function. What's step 4 that you wrote for me?
Wait, am I?
Find the y-intercept
I don't know why it's doing
by what?
that.
Which place value in my standard form? So if I have my standard form equation up here, what represents c? Negative 3. So what's my y-intercept?
I put it on the wrong line.
Oh, my y-intercept, the x will be 0, and the y value would be negative 3.
Wait. I thought you put the -5 on the y-intercept.
No, our y-intercept is going to be our c, which is negative 3. Okay? That negative 5 is the y-axis. Okay?
Why is it 0?
Hmm?
Why is the y-intercept x 0?
Because 0, the y-intercept, if you remember, my x value will be 0, then my y would be negative 3. Okay. I know that was a little rocky. That's okay, because we're going to do another example. Okay? Do we all have this down? All right. Let's take a look at example number 2. So example number 2, we're doing the exact same thing. We're going through the exact same process. It says find the vertex, the equation of the axis of symmetry, and the y-intercept of the function. So we need to use example number 2, y equals negative x squared plus 6x plus 4. We're going to use this quadratic function and find the following 3 things. Now, to start, what do I have to find first? According to step 1 on your notes, what's the first thing that I need to find?
The x.
Which is our axis of symmetry. Good. So we're going to find our axis of symmetry. Riley, what's my formula for the axis of symmetry?
X equals.
You can just tell me the straight up formula and we'll substitute numbers in just a minute.
B, negative b,
Mm-hmm.
and divided by
2 what? A. Good. Now, remember, it's going to be ax squared plus bx plus c. That's my standard form. All right. So I'm using the formula x equals negative b divided by 2 times a. So what am I going to substitute for b? What do I substitute for b? 6 over 2. And then what do I substitute for a? No, not x. Negative 1. Okay. Because if there's not a number in front of the variable, we know that there's a placeholder 1 in there. Okay, what's negative times 6?
Negative times 6, which would be negative 6.
Okay. And then my bottom, 2 times negative 1? Negative 2. And then my last step, what am I going to get? Negative 6 divided by negative 2, which is 3. Good. Okay. So my axis of symmetry is what?
3.
X equals 3. Good. So because now I know the x value, I can now find my y value. Okay? So step 2 and 3 basically says you're going to go back and take your original function, your quadratic function, which is y equals negative x squared plus 6x plus 4. Because we're trying to find the vertex. The vertex is made up of an ordered pair, which is the x value and the y value. Well, we know the x value, but we don't know the y value. But right here, if I substitute for x, I'll be able to find the y value. So what does x equal, you guys?
3.
3. So every time I see an x, what am I going to substitute for it?
3.
Good. So when I substitute, I put parentheses around the number I'm substituting for. Any questions on how I got this right here? How I got this step? What I knew to substitute?
Don't write. Oh yeah, good question. Don't write. Don't erase.
I won't erase. Okay, so now we use PEMDAS to go ahead and simplify it. So where do I start if I use PEMDAS, Jenna? Okay, do I have any parentheses or group of numbers in parentheses? Nope, then what? Exponents? Okay, now this negative is not part of this parenthesis. So do I put that in with it yet? No, I do my exponent first. So what's 3 squared? 9. Now when I bring that 9 down, because there's a negative on the outside of the parenthesis, what do I bring down with it? Okay, then after exponents, what can I do? Okay, so what's, my multiplication is right here, so what's 6 times 3?
27.
Try again. 6 times 3, help her out.
Oh, 18.
18, there it is.
And 9.
Hey, it's a Monday and a rainy Monday at that. And then I bring down my plus 4. Okay, now my last step, remember, PEMDAS is AS, addition, subtraction. They go at the same time working from left to right. So it doesn't matter if subtraction's first or addition's first. You're going to do whichever comes first working left to right because they're the same step. So negative 9 plus 18 is what?
9,
Okay, so then we have 9 plus 4.
13.
So what does my y equal? My y-axis value, not my y-intercept, 13. So my vertex then, remember, my vertex is made up of an ordered pair. So what's the x value of my vertex? And then what's my y value? Y equals what? 13.
Actually, we're at pencil.
Yeah, go ahead. Okay, now the y-intercept, where can I locate the y-intercept?
By the C.
By the c. So what number represents the c in my standard form? 4. So my y-intercept I write how?
0, 4.
Perfect. Good job. Oh, I'll get that later. Don't worry about that.
Oh, like he's shooting at me. I don't know.
Okay. Turn the page. We're going to slip gear or change it up a little bit. Now we're going to talk about maximum and minimum values. So we're going to talk about if it opens up or opens down and what does that mean. Okay. So, if it opens up, that means that the vertex is all the way at the bottom. It means it's a minimum, okay? So if it opens up, like it could hold water, that's going to be a minimum. That means your vertex is going to be the low point, the lowest point on the graph. Now, that basically means that your A, this A value here, is positive. So in standard form, if you notice that your first number in front of the x squared, the A value, is positive, it's going to have a minimum, okay? Basically, all that means is that A is greater than or equal to 0. Please put that equal then sign under your greater than sign. So put that half equal sign. Where it says A is greater than 0, go ahead and put that or equal to, like what my notes has there. So now, if it opens down, that means that your first coefficient is negative. So your A is negative. And that means that your parabola is going to have, or your vertex is going to be a maximum. It's going to be at the highest point of your graph, which means A, or the function, is less than or equal to 0. So go ahead and put that less than or equal to sign under that greater than sign as well. Oh, you already got it. Thanks, Maddie. Okay. So, again, opens up, it means the vertex is the lowest point. Or excuse me, opens down, that means the vertex is the highest point. It's a maximum. And you can actually tell by either one, it's easy to look at the graph, but you can also tell by just looking at the quadratic function, right? At our A value. Now, when we're talking about the maximum and minimum values, you guys are going to be asked to find the domain and the range as well. Now, the domain, what you need to know about the domain is that it's all real numbers. Does anybody remember how to write the all real number sign? No, that's at. Isn't it kind of like this?
Sure, yeah, let's put that.
Wait, I thought it was like an A or not.
How do you write your all real numbers? How'd you guys write them? All real numbers, right?
Mm-mm.
How do you write them?
Like this.
Let me see. No.
Okay.
No, you can just do them like this. Pretty sure.
Remember that.
We didn't do that last
I
time. We had to
did.
use all real.
I'll put an A and an R.
Okay.
And
Make your sign for all real numbers and we'll find a better one. Okay, so basically domain all real numbers.
is that our sign?
Yeah, that's the sign we're going to use.
What is
This is what we used in algebra with mallet.
We don't. No. No.
Yeah, that's what we used with mallet.
I don't.
Okay, we'll come back. I'll come back and I'll show what we use. Okay, range. The range is going to be a lot of verbal usage again, a lot of words. So range is going to be all the numbers greater than or equal to the minimum or all the real numbers less than or equal to the maximum. It honestly just depends on what you get for your minimum or your maximum, okay? All right. So that's okay.
The negative.
Okay, so we're going to go ahead and take a look at example number 1. So example number 1, we don't have a graph to look at. Example number 1, we just have the quadratic function to look at, okay? So based on what the quadratic function is saying, what we need to do is determine whether the function has a maximum or a minimum value. So in order to look to see if it has a maximum or minimum value, where do I look at for my standard form? Which part of my function am I looking at? A, B, or C? A, B, or C? A. So I'm going to look at my A. Now, my A represents the number in front of the x squared. Is that positive or negative? Is that a positive or negative number? Positive. If my A is a positive, is it going to be a maximum or a minimum? A minimum. So determine whether the function has a maximum or a minimum value. Well, because it's a positive, it's going to have a minimum value. Now, it wants me to state the maximum or minimum value. So, how do I do that? What is the maximum or minimum value, you guys?
Positive 2.
It's the vertex, right? So basically, we need to figure out what the vertex is. How do we find what the vertex is using a quadratic function, though?
We put in we solve for x.
Which is the axis of symmetry. Very good. So the first thing that we're going to do is have to solve for x, which is the axis of symmetry. So we're going to have to do x equals negative b divided by 2 times a. Okay? So using my quadratic function, what do I substitute for b?
Negative 4.
Okay? Divided by 2 times a. To what do I substitute for a?
2.
Okay. Negative times negative 4, so 2 negatives equal a.
Positive
And then what's 2 times 2?
4.
So then 4 divided by 4 is?
1.
Okay, so that's my x value. And now we need to figure out what my y value is. So how do I find my y value? So to find the vertex, I have to have an x and a y. So how am I going to find my y value? So this really represents y equals. So the function of x is the output, which is still y, which is our output. So what do I use? What do I do? I like how Hannah's looking back at her notes to try to get an idea.
You guys just say x is in the equation.
Yeah, we're going to substitute. So I'm going to use my quadratic function. So the function of x equals, so when I see that x, what do I substitute for it? 1. Because I said here, x equals 1. So I substitute 1 for my x. Minus 4, substitute x, so 1, minus 1. Okay? Now we use PEMDAS. So what do I do first here? Or 1 to the second power, because you're going to do your exponents. So what's 1 to the second power? So 1 times 1 is? Okay, so then. Okay, and then after we do our exponents, my next step is to what's my next? Solve how? That's what I'm working on.
2 times 1.
So I'm multiplying, which is,
2.
and then
-4.
times
-1.
1, which is
Down a little bit.
-3.
-4 times 1 is -4, right? And then 1.
And we equal
Okay, so then what's our last step? Simplify it. So we're going to add or subtract, working left to right. So 2 minus 4 is,
-2.
and -2 minus 1 is? -3. Okay, so we know now that my vertex is going to be 1, -3. Now, the minimum or maximum is where it's going to be the high point or the low point. So we're going to worry about the y, okay? So the y is what brings us up or down, right? So what's the minimum going to be? What's the minimum value going to be?
It is gonna be
I'm running out of room.
Sorry, write small. What's the minimum value going to be? -3, just -3, because the minimum value is what takes us to the high point or to the low point. So it's going to be the y spot there. But we need to find the vertex in order to find the minimum value. Okay. Now we're going to state the domain and range for the function. All right, so the domain is what?
all real numbers.
All real numbers. That looks like pi. I'm writing pi there, aren't I?
Yeah.
I'm going to figure that out. All real numbers. And then the range, okay, so this is where,
The range.
okay, what we're going to do, I keep saying okay, sorry about that. We're going to use the function of x. So whatever they start with our quadratic function, that's what we use. So the function of x. Now, because it's a minimum value, am I going to use a greater than or equal sign or less than or equal sign? Because it's a minimum value, because it's a minimum, I'm going to use what sign, Maddie? Greater than or equal to. And then what was our minimum?
-3.
-3. And that's our domain. Okay? So the range is basically your minimum or maximum value.
It's 10:44.
Great. We have 6 more minutes to finish this last one.
Wait, what time do we get? I thought we get out of here at 55.
No. 50. I don't know. Maybe 55.
50.
All right. Ready for the last example? Okay, let's take a look at it. Danny, have it down?
Will it take 4 minutes to do it?
Possibly. Okay, here we go. So again, we're following the exact same steps. We're trying to identify the exact same thing. So we're going to determine whether the function has a maximum or a minimum value. So just looking at the function, is it maximum or minimum?
Maximum.
How do you know that?
Basically, it's a -a.
Good, because right here the a is a negative, so we know it's going to be a maximum value. Now, it says to state the maximum or minimum value. Hannah said last time in order to find what the maximum or minimum value, remember it's either the highest point or the lowest point, which is the vertex. So it's a vertex maximum. We need to find the order pair for the vertex. And in order to do that, the first thing I need to find is the x value, which somebody else said in order to find the x value, I first need to find the axis of symmetry. So axis of symmetry is x equals -b over 2 times A. So what do I substitute for B?
Negative 2.
Divided by 2 times what do I substitute for A?
1.
Negative 1.
Negative 1, yeah, don't forget that negative 1. Okay, so what's negative times negative 2? So what's 2 negatives equal?
Negative 1.
What? Negative times negative 2? 2 negatives equal a...
Oh, I'm way further ahead. It's positive 2.
Okay, and then 2 times negative 1? Negative 2, okay. Then divide them out. 2 divided by negative 2 is? Negative 1. So the x value is negative 1. What do I do with this information from here? Find the y by substituting it back into my original function. So I have the function of x. So the output is going to be, so I substitute negative 1, you said? Minus 2, substitute negative 1, minus 2. Okay? Now my exponent, it's negative 1 squared. So it's negative 1 times negative 1. 1. Now, because I have the negative in front of the parentheses, I'm going to bring that negative down. Okay?
I'm just guessing that.
I'm going to go ahead and multiply this as I'm bringing them down. What's negative 2 times negative 1?
1? No.
I think I heard somebody say it. Positive 2.
Yeah, Bob.
And then I bring down negative 2. All right, I'm ready for my last step. Now, remember, the function of x is basically the output, which still means y. So then what's that going to equal? So negative 1 plus 2.
Negative 1, comma, negative.
So what's negative 1 plus 2
1.
minus 2?
Negative 1.
Okay. So then my vertex is going to be what? What's my ordered pair that I'm using for my vertex?
Negative 1, comma, negative 1.
Okay. Now, it wants me to state the maximum or minimum. Well, we already determined that it's a maximum value, right? So the maximum is how high or how low my graph is. So what's my maximum going to be?
Negative 1.
Negative 1, because it's going to be based on the y axis. All right. Last thing we're going to do. State the domain. Well, the domain every single time is going to be what?
All real numbers.
All real numbers. And then the range. Okay. Now my range, what did I use to start with? What's my output? What am I using to show my output? Well, okay, you're right there. Less than or equal, but my output is going to be f of x is less than or equal to, and then what's your maximum?
Negative 1.
Negative 1.